So let's discuss the 55th bit of this question. We have already determined the net power output, which was 402 kilowatts. Now what is given is if it had been an isentropic process which follows this law, T2 by T1 is equal to P2 by P1, gamma is 1 by gamma, and gamma is 1.4 specific heat ratio, the isentropic efficiency of the turbine. So what is given is you have at constant pressure processes, it is given. So you have two set of pressure processes, okay, and I'm plotting in a TS diagram. The actual case is given in the first 54th bit, that is 2 here and 1 here, but the ideal case would have been a drop like this. This is the ideal case, which is 3, okay, 1 to 3. So what is given in the first bit is 1 to 2, where 1 is 1000 Kelvin and 2 is 600 Kelvin. But what is asked is if it would have followed 1 to 3, that would have been the perfect process, which happens only in ideal case, which is isentropic process, and the work done would have been maximum. Okay, so but the real world turbines don't work that way. Real world turbine would most of the time would follow process 1 to 2. So the isentropic efficiency is work done in the actual case, and that you are comparing with the work done in the ideal case, which is the isentropic process. And we know that work done is the difference in the enthalpies between 1 to 2, which is the actual case, which we did in the 54th bit, by the ratio of in the ideal case. So that enthalpy, change in enthalpy for the ideal gas, boils down to the change in temperature. So it's Cp T1 minus T2 by Cp T1 minus T3. So it basically boils down to the difference in the temperatures. Okay, now we know T1 minus T3 is 1000 minus 400 by 1000 minus T3. Now T3 is something which I don't know, but I know the pressure states P1 and P. These are the constant pressure lines. So I know the pressure state, so I can use this isentropic law to find out what is the T3. So T3 by T1 is P3 by P1 gamma minus 1 by gamma. So going by this, T3 is something which I need to find. T1 is 1000. Now P3 is 100 kPa. So it's 101,325. I'm writing in MPa, and P1 is 1.0132. So this comes out to be gamma minus 1, which is 0.4 by 1.4, and this value, so this value to me is 0.1, roughly it's 0.1 whole power 0.4 by 1.4. So T3 comes out to be 517. If you use a calculator to find out this comes out to be 517.94, so roughly 518. So if I use that here, the efficiency value which I'm getting is around 82.8%, close to 83. So 83 is the answer. 83, close to 83 is the 83% is the efficiency, isentropic efficiency. Remember that isentropic efficiency is always the ratio of the actual work done by the turbine to the ratio of ideal isentropic work done. Thank you.